Um, so the exam is Friday, the in-class portion, there's 10 problems on it. The take-home portion is just Sunday, I think there's also 10 problems on that one. But the in-class is a lot shorter. It's due at 11:59 PM Eastern Time on Sunday night. I went through the in-class exam again and wrote formulas down. So just to make sure you have all the formulas, if you didn't put them all together when we were doing them earlier from last class. Such a probability. So if we're finding the complement of the probability of A, some books use a line over it, some use the C, but this would be A's complement. If 1 minus the probability of A. Or you could put so the complement means the opposite. You're finding the complement of the probability of A, then it's the probability of not A, which is 1 minus the probability of A. When you're finding mutually exclusive, you have to show that the probability of A and B equals 0. If it does not equal 0, then they are not mutually exclusive. independent and dependent, there was two things when you're explaining it that I'm looking for. So independent, did we replace them or not replace them? Each one is independent of the next one. So your probabilities stay the same. So you replace. This one was marbles that we did, but replace items. Probability stays the same. So remember when you have two independent events, or not two, when you're independent, it was the marble problem. We replaced it each time, so the probability stayed the same. So I'm looking for both things when you're explaining it. One, that you need to replace it so the probability stay the same. So those two things. Dependent, same thing, but opposite. You do not replace. Which then makes the probabilities change. Each event depends on what happened the time before because you didn't put it back in. So remember, the next event depends on what happened before. That's dependent. Independent, each one, the probabilities are the same, doesn't change. If you have a probability distribution, there's one where you have to explain if it is or it is not a probability distribution. Remember, for a probability distribution, when you add up the probabilities, what do they have to equal? And each probability has to be between what two numbers? And it can equal it. 0 less than or equal to each probability less than or equal to 1. So when you're checking its probability distribution, add up your probability row and it needs to add to 1. And every probability has to be between 0 and 1. So if it's not a probability distribution, I want you to tell me which one it fails or if it fails both of them. So when you're explaining it, you need to use both of these. Show that they add up to 1 and say that they're all between 0 and 1. Or if one of them's not, let's say it's not and they don't add to 1. But I want both of those in there. Any questions? I went and highlighted those highlights. I put this one up on Blackboard. They are the ones that were on the in class. Not that they're not also in the take home, but they are from the in class. Any questions so far? The binomial distribution, the one on the in class, you only have to use the formula. The one on the take home, you use a formula and then you explain how to use a table also. But the one in class, you only need the formula. Oops, this should be an offer. So this is your formula and you'll have to write it out, plug in the values, and then just use the calculator to solve it. So you don't have to memorize the combination forms. Use your calculator. The mean is n times p. The variance is n times p times q. And the standard deviation is. So for binomial distribution, you need to memorize this. I think it's I made it two separate problems. For the normal distribution, so you need to be able to read the table. I only used one, so everything's positive. So I'll just make a copy of this one. So if you think it needs to be on the other table, then you did something. Calculate it again. So this is your Z value. And then if you have a sample, mean is the same as the mean in the problem. The standard deviation is the original divided by the square root of n. And the Z value. Oh. I can't remember if we had to find X. Let me just give you the plan. I think we. When you enter this, if you're entering it all at once, it needs to be in parentheses. Same thing here. And if you need to find the X. No, I know you don't need to find the X. You just have to find the Z value. So there's one problem where you're using the sample size and you have to find the mean, the standard deviation, and the Z value. Any questions on any of those? Any that you want to see a problem with? This, the sampling one? Um, Okay, so we have the speed of tornadoes following a normal distribution with a mean of 79 and a standard deviation of 12. Is a sampling of 10, is the normal necessary? You have a sampling of 10. Do you need the normal distribution? I think someone say yes. Why? Mhm. So we do need the normal because our sample is less than 30. Because our sample size, which is 10, is less than 30, we do need the assumption. If it's greater than 30, you don't need that. That's what allows you to use that normal table. So I asked that, I know, and then I asked for a couple other things. Squeeze all this. I don't know if I take this off. It'll mess up. So find the mean and the standard deviation. So 10 didn't. Now, on any that you're rounding for mean and standard deviation or variance, remember, you do one decimal place further than your data. I would assume it would be integers because 79 is our average. But remember, the mean is equal to the mean of the population. So this is just 70. The standard deviation is the original divided by the square root of n. And you can leave it like that. Because when you plug it into a problem, if you round, depending on what you round to, you're going to get different values for your z, and it's not going to be exact. So when you're plugging into z, you should not use the rounded version. Any questions on that part? Z, whenever you're doing z, especially on the take home, there's probably one on here. But on the take home, z should always be rounded 2 decimal places because that's what your table uses. Well, let's finish this one first. So if we're using the sample of 10 and we get a mean of 80, what's the z-score? So that's when you use this one, when you're working with your sample and instead of one x value, like if it was a tornado was going at a speed of 80 miles per hour, then you would use this one because you're only using one. If you're finding the average from the sample, then use this one. And the biggest problems are plugging it in. Oh, does anyone need a calculator? I fixed the decimal places now on that one. Mhm. Anyone else? So a z value is always rounded 2 decimal places. Are you getting 0.26? You have to put these in parentheses. Unless you have a fraction bar. I know the TI-84 has a fraction bar, but I don't know how to use this. Any questions on that? So there's one problem on the test similar to that. There's 3 normal distribution, and this is one.
I get point some.
Got that too. Got 2 6.
This is 0, 2, that's.
Make sure. 80 minus 79 is 1. 1 divided by, no, you should get 0.26. Does anyone else get, anyone else getting something different than this? Okay, what's happening is you're not putting parentheses around the denominator like I said you had. If you don't put parentheses around this, you're getting a 0 here. It's a different answer. If you take 1 and divide by 12 and divide by the square root of 10, it is different than this. They are not the same. Any questions on that one? Any questions on reading the normal table? Yes, no?
Can you show me do it from when you start in the middle and go out?
On the exam, the take home, you can use the tables here. You just open your book and go to appendix from here, go to appendix A. Binomial is this one and the standard normal. You shouldn't need anything else. We haven't covered this bottom. So when we're looking at the table, over here, this is the second decimal place for Z. So if you have a Z value, you read on the outside, like negative 3.45, negative 3.4 is here, and then you go over to 5 here, and it would be this. Negative 2.96, negative 2.9, and then 6 is here. Negative 2.96, it would be this value. Now, as you go lower, it doesn't necessarily show those. On the chart that I will give you, it's just the positives, but it will show it. So if you think of a normal curve, Z is on the outside. When you're reading Z, you're using the outside part. Anything under here, that's on the inside. And it needs to be below. So you're always working with below. If you're given above, you need to change that. So if we had this shaded, and to make things simple, use a quarter. 0.25, we wouldn't look this up on the table because the table uses everything below. And you always want to check that because when we get to the T table, it does it the opposite. So I always look just to remember. So it's shading below to find the area below You subtract it from 1. So this is the area inside, you look inside the table and work out. So we would go into the table and look for 0.75. So we'd be looking in here. And there is one on the test where I just show you the area shaded inside and you just give me the Z value. I think it's 3. So we're looking for 0.75 here. It's between these two. We have 486. So since it's in between, you need to decide which one it's closest to. If it is right in the middle, go with the larger one. It's closer to this one. Because if I subtract these, I get 0.0014. This one would be 0.0017, so it's closer to this one. Any questions on that part? Okay, so we're using this. So then we need to read across. So we go all the way across. We know it's 0.6. Now to find the second one, you go up. So this gives you the beginning. Then you go up to find the next value. Or you can count. This starts with 0. 0, 1, 2, 3, 4, 5, 6, 7. But if we went all the way up. 7. Questions on that? So when you have the area inside here, you work on the inside of the graph and then go out. If you're given the Z value, then you look on the outside and go in. And it's always giving you what's below. So if you have or need what's above, you need to subtract from 1. That's beautiful. Now, how about if we want to find this Z value? Would we have to subtract this from 1? No, because it's below. So then we would just look this on the outside or inside? Inside. We're going to work on the inside because it's inside the graph what we have. Z is on the outside. We're looking for Z. So 0.36 inside the graph, it's inside the chart. So we're looking for 0.36. In this one, we know it should be negative because it's below 0.5. 0.3. So somewhere in here, there we go. Between those two. So we know it's between those two. Which one's it closer to? It's 0032 from this one. This one, it's just 0006, so it's closer to this one. You could subtract 0.36 from both of them to see which closer. So it's this one. So then we go across. And get negative 0.3. And then we need to find this other place by going up or counting. We're using that one here. 0, 1, 2, 3, 4, 5, 6. Any questions on them? Does that help?
Yeah, thank you.
So there is one on the test where I give you an area under the curve and I ask you to find Z. Very similar to one of those two we just did. Any questions on it? Any other question? Okay, let's do one more Z just to make sure. Of the other type, because there's 3 problems. The one was the sampling that we did, and then one like this, and then the other one's just the basic where you have to find the Z value. So if we have the speed of tornadoes following a normal distribution with a mean of 79 and the standard deviation of 12, what's the probability? Notice this one doesn't use the sampling of 10. So you would only do it for one. It would be the regular Z value. Because we don't have a sample, it's just a tornado. So since it's just one, it's just the regular. So we want to find the probability it's faster than 82 miles per hour. It's a normal distribution. So we can use the Z value and then find it in the table and check that I know it's going to be positive. The value is always rounded 2 decimal places because that's what the table uses. Comes out. Not a very good number tape, but So we found our Z value. Did you get 0.25? If you didn't, you probably didn't put your numerator in parentheses. Are we shading above or below? Above. Because we said faster then. We said slower, then we would shade below.
Wait, what's the number again? 0.8.
Wait, what?
Oh, I was asking who was this.
Oh. So we'll look for that and I'll take, oh, I did have it here. Okay. 0.2, 0, 1, 2, 3, 4, 5. So that's a Z value. I use the outside values. I go to 0.2 and then it starts with 0 on the top. So 0, 1, 2, 3, 4, 5. It would be this one. 5, 9, 8, 7. Now, is that the shaded area or is that the area that's not shaded? Think about the normal curve. Below. It's below. So when we look under here, it's giving us below our Z value. How do we get above? Subtract it from here. So if we said slower than 82 miles per hour, we would have used the 0.5987. If we say larger, then we have to subtract it from 1. So the probability that a tornado is faster is 0.4, 0.4013, 40%. 40% of tornadoes are faster than 82 miles per hour. If it doesn't specify percent, it just says probability, and it doesn't say fraction decimal, then it's up to you. But if it says a percent, make sure you write a percent. Percentile should be as a percent. I think percentiles on the take. I didn't put it on. So this one you would not.
Yeah, yes.
Yeah, I would not ask for a fraction from the normal table. Forget which ones I used that on. The probability of like pulling a card or rolling a die where you would start out with fractions. And then I asked for, it's only one problem, fraction decimal. Any other questions? Yes.
So you did the 1 minus because it was the faster, like.
Right,
faster
because
than-
we wanted above. If we wanted below, then I would have used the other.
Okay.
This is an important, normal distribution is really important. We're gonna do confidence intervals with it. We're gonna do hypothesis tests with it. That's why there's 3 of them on your in class. And then, I don't remember how many's on the take home, but I remember it's a long problem. I took it this morning. Another thing, I don't know if you've looked at the test yet. The take home one, I put the chapters so then if you are looking back, like this one says chapter 4 and all the problems for chapter 4 together. And then this 6 starts chapter 5. So I put the chapters that will help you. So normal's chapter 6, yeah, it's one problem, but it's got a lot of parts, just making sure you understand the curve. Because it wasn't a big chapter, but it's an important chapter. Make sure tomorrow, so look over your class, try your take home. I'll take any other questions though on the in-class. But then is there any other questions?
Can you go back to the review?
Back to the review, yeah. So on the review, the highlighted ones, that's what's on the in-class. Was there certain you had a question on?
Yeah, I just was gonna run.
These are, on Blackboard. If you open it up, it's highlighted down.
Oh, it's happening.
Um, These are all highlighted now on Blackboard, so look at those, see where you have questions, look at the problems that we did last class. If you were not here last class, there's a video of it. I don't remember if I put it up. But I'll put it up right on the class. Okay, if you still have questions, we have 5 minutes, but if you don't, I will see you tomorrow.